Okay, we're back here again. Review 4-2. James has an investment with an interest rate that fluctuates. So he has saved the balances of his last several statements. Write an exponential model. Wow, that doesn't need to be plural. To represent the data and estimate what his balance will be after 2 years. So we'll just start. It says write an exponential model, so that means divide. No matter what's going on, we're going to divide. So divide number 1 by number 2. So 510 divided by 500. 510 divided by 500 is 1.02. 1.02. 525 divided by 510 is 1.029. So that's 1.03. 541 divided by 525. 541 divided by 525. We get 1.03 again. 1.03. 561 divided by 541, we get 103.6. So that's really 104.04. And that's that. So they're all different. They're really, really close. And they tell us to make an exponential model out of it. So what we're going to do is we're going to average them. So to find the average B value, the average rate, we're going to add them all up. So that's 1.02 plus 1.03 plus 1.0, no, not 03 again, because there's two of them, 0.04, and we're going to divide it by 4. So that's 1.02 plus 1.03 plus 1.03 plus 1.04. Hit enter, and then divide by 4, because there are 4 ratios. Now those 5 data points, but there's only 4 ratios. And we get the average B value to be 1.03. So we have our B value, we have our starting point, which is our A value, and we can write our equation. Y equals 500, what was that? 500 times 1.03 to the x. Okay? But that's not it. It says, what will his balance be after 2 years? So we're going to estimate what his balance will be after 2 years. Well, remember, this is in months, so we can't just put a 2 in there. 2 years is 24 months, so plug 24 in for x. And remember, that's an exponent. It's not 103 times x. It's 1.03 to the x. So 500 times 1.03 raised to the power of 24, and we get $1,016.39, 39.7. So it really rounds up to be 1016.40. That's how much we expect to have after 2 years or 24 months. All right, let's go do number 11 real fast. Okay, 11. Cynthia is measuring the rate at which uranium decays. She has recorded the amount of remaining after every day. So you've got a radioactive thing that's decaying. Write an exponential model for the situation and estimate how much will remain after a year. Okay, so we're decaying. So this is, it says write an exponential model. So we'll divide. So 41 divided by 50. That's 0.82. So that's 0.82. 35 divided by 41. That's 0.85. 0.85. 27 divided by 35. That's 0.77. 20 divided by 27. That's 0.74. And so again, we need our average B value. So we're going to take 0.82 plus 0.85 plus 0.77 plus 0.74, and we will divide it by the number, which is 4. So here we go. 0.82 plus 0.85 plus 0.77 plus 0.74. Hit enter. And divide by 4, because there's 4 ratios. Yes, there are 5 data points. And it's 0.795, which I'll round the 5 up to 9, which makes it a 0.80. So that's going to be our B value. So we can now write our equation. Ooh, we are missing the starting point. Ooh. So basically, to back up to 0, I need to back up this left side. And we're going to back up using our average of 0.80. So instead of dividing, we're going to multiply 50 times 0.8, and we get 62.5, which I'll leave it as 62.5. Okay? So, starting point is 62.5, so y equals 62.5 times 0.8 to the x. So that's the first half of the question. The second question says, how much will remain after a year? All right, well, a year is 365 days, so I'm going to take 365 and plug it in for x, right there. So after I do that, y equals 62.5 times 0.8 raised to the 365th power. That's going to be a really small number. Ooh, and my calculator spits out the number 2.65 e to the negative 34th, which basically means you need to move this decimal that direction 34 times. It's a very small number. So this is probably a poorly constructed equation. But you get the point of what's going on. So you can build the equation, you know where to plug the 635. Yeah, the answer at the end is funky, but so what? Live with it.